All right, last section of chapter 4, we are talking about two other congruent shortcuts, okay? The angle side angle shortcut. So if two angles and the included side of one triangle are congruent to their corresponding partners, two angles and another included side in a second triangle, then the triangles are congruent. Okay, so in this pair of triangles over here, angle B is congruent to angle E. Angle A is congruent to angle D. And then basically the side that connects those two angles. Okay, so AB and ED. Okay, if those three pieces are congruent, then we can say that the triangles, in this case, triangle ABC and triangle DEF are congruent. Okay, so using angle side angle in proofs. Okay, just remember for these two column proofs, we copy the given information. Okay, that's our first statement. Our reason is because the information was given to us. All right, and we do have one piece here, angle PSQ, right here, is congruent to angle RSQ. Okay, that's one piece of three that we need to show triangle congruence. Okay, now QS, that line segment, also bisects angle PQR. Okay, so angle PQS and angle RQS are congruent. By that definition of bisect that was in our given information. Okay. One final piece of information, remember after you've used the given information as much as you can, let's go ahead and look at that picture. Okay, I see two triangles that share that side SQ. So I'm going to say SQ is congruent to itself by that reflexive property. Okay, which lets me say that my two triangles are congruent. Triangle PQS and triangle RQS. Okay, and again, we've got two angles, angle PSQ to RSQ and PQS to RQS, and that included side. So that's our angle side angle shortcut. Okay. Now from here, since we have those congruent triangles, this is where we could use CPCTC. And if we wanted to, or if we were asked to prove, maybe we were asked to prove PQ is congruent to RQ, or PS is congruent to RS. Okay. But if we're trying to prove something other than triangles are congruent, we have to prove those triangles congruent first, and then we can say that those parts are congruent as well. Okay, now here we've got a flowchart proof that we're going to work on. Okay, first piece of given information is that ZX bisects angle WZY. Okay. When we see that vocab, if WZY is bisected, then angle WZX is congruent to angle YZX. Okay. That second piece of given information, the same segment is bisecting angle YXW. Okay, again, that is information that is just given to us. Okay. When I see that vocab word, I want to use that definition. So now I've got WXZ congruent to YXZ. Okay, and then if I look at my picture, because I've used both pieces of given information, XZ is congruent to itself. That's that reflexive property. Okay, and all three of those pieces come together to let us say that triangle WXZ is congruent to triangle YXZ by angle, side, angle. Okay. And our final shortcut, if two angles and the excluded side. So this time we still have two angles, but it's a side that is only touching one of our angles. Okay. And so just like that first two pairs of triangles we saw in these notes, angle B is congruent to angle E. Okay. We've got angle A congruent to angle D. All right, but now notice this side that is congruent, or the pair of corresponding sides, only touches one of our two congruent angles. BC is congruent to EF. Okay, so now we're going to prove some triangles congruent using angle, side, angle. All right. First here in my given information, remember this given information is word for word or symbol for symbol. Goes into that first statements box. Okay. Now, if I mark those, angle DAC is up here. Maybe. There we go. DAC. Angle BEC is this angle down here. Okay. Those are congruent. Now DC, this segment is congruent to DC. Okay. You will not see this very often, but the two triangles that I'm looking at both share angle C. Okay, and just like line segments, angles can be congruent to themselves by the reflexive property. Okay, so now I can say triangle ACD, so right here, is congruent to triangle ECB. Okay, this is two overlapping triangles. And if I were to draw one of these, like if I pull out triangle ACD, okay, DC is marked, angle C is marked, and angle A is marked here. That's our angle, side shortcut. Okay. And last but not least, we've got, first of all, ignore this. This is extra information. There's not even an X, a W, X, Y, or Z in the picture. Okay. But the information that we're given, we're going to look at RQ parallel to ST. Okay. And remember, when we see parallel, we want to think alternate interior angles. All right. So we can look at either pair, but we're going to look at angle R congruent to angle T. Okay, that's one pair of alternate interior angles. All right, but we also have given information RQ is congruent to ST. Okay, and then if we look at our picture, RUQ and TUS are congruent. Those are vertical angles. Okay, and those three pieces together, let us say that triangle RUQ is congruent to triangle TUS by that angle, side shortcut. And that is it for chapter 4 notes.